So electric field in 2D. All right, so I'm gonna do, this is from worksheet 2, I think, that you have in Canvas. I'm going to solve the first problem. And then after that, you should do 2, 3, and then pick one of these, 4 or 5. So yeah, so this one is, I'm gonna put here me, this is Mr. Klapik, and then yours, I'm gonna put here homework. Let's just make it more specific. So numbers, let's do this, 2 and then 4. And in addition to these, I'm gonna give you something else from, there's gonna be more to the homework, but for now, these two. All right, so problem 1, what we have here is 2 charges. Both are positive, so I have a positive charge. Let's let's just work with this picture here that I have. So I have a positive charge Q1, and this Q1, I'm going to write this here. So this is where I have Q1. Let's maybe use a different color. Here's Q1, and Q1 is 4 microcoulombs. And then I have Q2 at this place, and Q2 is 5 microcoulombs. And then the question is, what is the electric field at this point of interest? Now obviously there's electric field everywhere within the space here, but I'm interested in electric field only at this location. And the way to think about it is that you can add electric field the same way you add forces. So if you want to find electric field at this point, you have to find all of the contributing factors. So there's an electric field E1, and let's see, this is in red, so I'm going to put this in red. There's an electric field E1 which points in this direction due to Q1. Now note that Q1 is positive, right? This is a positive charge. If it's a positive charge, electric field always points away from the positive. So let me put this up here. We have a positive charge, electric field always points away from the positive charge. And so if this is plus, then at this point, electric field points, in this direction. Now the other charge, Q2, is also positive. This is also plus 5. Therefore, at the point of interest, electric field due to this charge is going to point away. And so this would be E2, which is due to Q2, and just points in this direction because, again, this is a positive charge. So I have a plus here and I have a plus on the other side. Okay, so now that I have the directions of both of these, what I want to do now is find the sum of them. And the sum of them is going to be a field that, well, E net is what I'm after. So let me state this here. I want to find E net at the point of interest, and that E net is the sum of the two fields. So I have E1 plus E2. Now these are vectors, these are into these. I'm gonna have to add these two vectors. To figure out what's going on. And if you want a picture for this, just add the two vectors. So if you want to figure out in which direction E net points, then you add the two vectors, and then your E net is going to point. Oh, that's not, I guess it will do. It's just going to point in this direction. So this is E net, although it's not as visible as I would want it to be, but it will work. There's your E net. So maybe I'll put this here. E net points in that direction. That would imply that the force on, well, let's just leave it there. So E net points in this direction, and we'll come back to the picture of the electric field when we get to part C. All right, so to figure this out, we need to find E1. So first E1, that would be K. The equation for the electric field is KQ over R squared. So this would be KQ1 over R squared. Equation for the electric field due to the second charge would be KQ2 over R squared. These equations will give me the magnitudes of individual fields. So this one here, that's 8.99 times 10 to the 9th times Q1. Q1 is 4 microcoulombs. Micro is 10 to the minus 6th divided by the distance. I have to figure out the distance. All right, well, I have to figure out the distance. But let me write this here, 8.99 times 10 to the 9th times 5 microcoulombs divided by, again, the distance. So what I have to do is determine this distance here. And let's call this R1 because it is due to Q1. And let's call the other one R2 because it is from Q2. Now to figure this out, that shouldn't be too difficult. So let's see what geometry we have. X1 is -2, so this is 2 centimeters. So keep in mind this is 0.02 meters, and the other one is 0.03 meters. That's meters. That's meters. And then what is the height? This thing is 4 centimeters. So this is 0.04 of a meter. Okay, so I have 0.3. I have 0.03. 0.04 and 0.02, so let's figure out R1 and R2. So this is 0.05 meters. This is a right triangle, so 0.03 squared plus 0.04 squared equals 0.05 squared, and then the other distance is 0.0, let's say I just did that, 0.045. So R1 is, let me write R1 out here. R1 is 0.045 meters. So 0.02 squared plus 0.04 squared equals 0.045 squared. All right, I have these distances. Let's put them in. So maybe, I guess I'll keep this. This is I'll keep the color 0.045 squared. And then the other one was 0.05 squared. All right, so let's calculate and see what we get. All right, so what I get is 1.78 times 10 to the 7th for the first one and 1.80 times 10 to the 7th for the second one. They're basically the same in magnitude. Okay, so I have these two. Now the next thing is to, I can't just add them up to get it in it, because what I have to do is I have to do it vectorially, right? So what I have is, I have to find the x and y components for each one. So let me redraw the picture here. I have point of interest, E1 points to the left. So E1 points like this. I wanted this in blue. E1 points, I see. All right, so E1 points to the left. This is U1, and this thing is going to have the x component pointing in this direction, so E1x, and it's going to have the y component pointing in this direction, so E1y. I need to find the angle. Shouldn't be too difficult, so here's the angle. This angle is the same as this angle, right? This angle here is the same as this angle, so let's figure this out. Theta, theta. We could do sine, cosine, or tangent for that matter, but let's do tangent. So tangent of theta, that's going to be 0.04 over 0.03, and that's going to give us theta of 53 degrees. So theta is 53 degrees, and now I can figure out E1x and E1y. So E1x is going to be 1.78 times 10 to the 7th times cosine of 53. We'll figure this out. E1y is going to be 1.78 times 10 to the 7th times the sine of 53. All right, so let's get these two. So I get 1.1 times 10 to the 7th and 1.4 times 10 to the 7th, and I should add units to this. So this is newtons per coulombs. This is newtons per coulombs. Right, so I have x and y components for E1. I could put it like this then, E1 and the x component 1.1 times 10 to the 7th, comma 1.4 times 10 to the 7th, but now I have to pay attention to the signs. So the x component of this is, well anyway, so the x component of this one is negative, and then the y component is positive, but all of this was actually E2 that I was calculating here. So let's relabel this as E2. So that's 2, 2, and 2. See, if you look at this one here, that's E2. So this should be E2x, E2x, and this is E2. Okay, so I have E2. Now let's go ahead and figure out E1. Well, I guess it doesn't really matter because you just round anyways. Yeah, we're gonna round this thing. Let's just make them. I'm looking at this, so I have 1.78 and then 1.78. It's unfortunate, but it's not gonna make much of a difference. But I guess I should probably at least be consistent with the numbers. So if this is E2, then this really should be 1.80. So this should be 1.80. This should be 1.80. These must be very close anyways. Let's double check this. Yeah, so really nothing changes here, but yeah, it's just be consistent with the numbers. So what I was doing is E2, therefore 1.8 is what I should have here. This is what I have, 1.8. Okay, so this is correct. E2 here is negative 1.1 for the X component and then positive 1.4 for the Y component. Now let's move on to E1. So let's calculate E1, and I guess I'll move this thing up and we'll do it in red. So for E1, let's draw a picture maybe. I wonder if I could. All right, let's do it here. Yeah, let's do it here. So E1 points like this. I should have drawn it bigger. Oh well. So here's the E1x, and then you have E1y. Here's the angle theta, and that angle theta here is the same as this angle. Now let me get rid of this r, because it's in a way. Oh, that's interesting. That's all right. So we have this theta here. That's the same theta. This angle is the same as this angle, which is what I drew here. So if I want to figure out that angle, what I'm going to have to do is tangent. I could do tangent. I could use sine or cosine, but I'm going to do tangent of 0.04 over 0.02. That gives me theta as 63 degrees. That's 63 degrees here. All right, so now I can calculate E1x and E2x. So E1x equals 1.78, which will just make that 1.8, but 1.78 times 10 to the 7th times the cosine of 63, and then E2x is going to be 1.78 times 10 to the 7th times the sine of 63. Let's calculate these and see what we get. Okay, so this is what I got: 8.2 times 10 to the 6th and 1.6 times 10 to the 7th. So now I have, let me put this in the vector form. Now I have E1 in the vector form as the X component is 8.2 times 10 to the 6th, comma 1.6 times 10 to the 7th. So I have E2 and I have E1. And I'm ready to find ENet. ENet is just the sum of the two. So all I have to do is write here ENet equals at the X and Y components. So let's see. So for the X component, I have minus 2.8 times 10 to the 6th. I should double check that this makes sense. I just punched this in the calculator. And then the second, in the Y component, that's going to be 3. It's going to be 3 times 10 to the 7th. And that should do. Let's double check this X. Yeah, it makes sense. Okay, so I get, here's my ENet, negative 2.8 times 10 to the 6th and 3 times 10 to the 7th. And that kind of makes sense, because if I were to graph this, what I have here is that the X component points to the left and the Y component points up, and so ENet points somewhere in this direction, which is what I was expecting from the picture that I have here. Here's ENet. Okay, so find electric field, expression, the vector, find magnitude. Okay, we still have to find magnitude. This was part A. So this was part A. Now let's do part B, which is the magnitude, finding the magnitude. So ENet, the magnitude of this thing is going to be the EX component squared. So 2.8 times 10 to the 6th square this, plus 3 times 10 to the 7th square this. You can put negative in here. Doesn't really matter. You're squaring this anyways. And take the square root of it and see what we get. ENet, the magnitude of the electric field, equals, let's calculate that. So this gives us 3 times 10 to the 7th newtons per coulombs. Okay, so this is the strength of the electric field at that specific location. This here also includes the direction. Now part C, let's see what part C is. So in part C, we have to draw the electric field everywhere in this picture. So let's do that. Maybe what I'll do is I'll take, oh no, I don't want to do that. All right, let's just do that. So this is plus, that's plus. Now one of them is stronger than the other one, but not by much. Well, it's a relative statement, but So anyways, the electric field would point like this. And I'm going to put an arrow here, and of course at this location here it points, well, along the E-net. Somewhere from here I would have the electric field that points somewhat like that. And I'd have something along the same line here, something like that here, and then maybe I'll add this. I'm going to do one more here. I'm going to do something like that. This one here. I'll do this, this, and then I'll do buffer plus. Okay, I'll do that, and this should do. So there's electric field present everywhere in space, but we were specifically interested in one particular location, which is right here. And we found out that at this point, the electric field points in this direction. We found the exact components, and we found the exact components here, and we found the magnitude of it. Okay, so I gave you an example of finding electric field in 2D of a problem where you have to do that. And then yours are, what did I give you? Problems 2 and 4. So 2 meaning this one, and 4 meaning this one. So there's a problem in your textbook 21.65. Okay.